Basically, injection molding is a high volume production technique for mechanical parts. And it involves creating at times somewhat complex tool, which can be expensive, but then creating much lower cost individual pieces that you can churn out at a pretty rapid rate. Injection molding machines are really cool. Some of them are as big as a locomotive. And basically what they do is melt the plastic to create what's called a melt, inject it into a cavity, which creates the part, and then the mold itself will eject the part from the cavity. You pretty much can't turn your head without seeing some parts that have been injection molded, from the clamshell of your TV remote to potentially housings on some of your electronic modules. Trash cans can be injection molded, which would definitely be on the upper end of what you can do. But yeah, it's ubiquitous. For teams that have built 3D printed parts and are looking to go from prototype to higher volume, there's a couple of different fabrication techniques they could think about. I mean, as you noted, usually you'll start with 3D printing because you can pretty much print whatever you can design. And the focus there is more on just getting the thing to work rather than thinking about the design for manufacturer assembly. But once you've got that down and are thinking about how do I build, maybe 10 of them, that's probably still fine for 3D printing. As you start to think about 50, then 3D printing just becomes too slow and kind of expensive. So at that point, we think about what we call rubber molds or silicon molds. And basically what you do there is 3D print a master part with a good surface finish, so maybe stereolithography. So think of like a Formlabs type process. Put it in a 2 or multi-part mold made out of flexible silicon. And you'll basically put the male part of the mold in, build up the mold around it, and remove the original piece. And then you can pour with a variety of resins liquid into that. You typically would draw a vacuum to get rid of the bubbles, so you have a nice uniform part. And that will cure up. It probably takes a couple hours, I'd say, before it sets. And typically you'll get about 50, what we call 50 shots, or 50 units per mold. If you want to do even a couple hundred, then you may make multiple cavities or sets of molds to do that. From there, the next step is what we think of as soft tools. And these are definitely not soft. If you drop one on your toe, it's going to hurt. But it's basically using a metal machining or electro-discharge machine process to create the tool. The trick is, with a soft tool, you may get 5,000 to 50,000 shots out of it. What you're sacrificing is you're not going through a hardening process, which just takes a little extra time and money. And you also will typically not put in these things called cooling jackets, which help convert the resin or melt from a semi-liquid state to the hardened plastic super fast. So instead of a 30-second cycle time, maybe it's a 4-minute cycle time. To take your part, say from a 3D printed design, and make it injection ready, it depends on the complexity of the part, but typically 2 to 4 weeks would be standard. And then to take that part, which we'd call tool ready, and actually cut the tool, is anywhere from 4 to 8 weeks. And then at that point, after you've debugged the tool, a normal cycle time is from 20 to maybe 60 seconds. The other key thing to keep in mind is you need something called draft. So what's going to happen is when you injection mold a resin, as it cools, it's going to shrink slightly. And it's small. For ABS, it's about 0.5%. But when it does that, it's going to squeeze really hard onto any internal surface. And if you don't have draft, which is just a slight angle, you're going to get terrible scratch marks, and it's never going to come off. So if you think of a Dixie cup, like that's a classic drafted surface, so that it makes it much simpler to pop off. But then it will open up all sorts of complexity, because if you have really tall parts, then the draft is going to be considerable, and what does that do to your dimensions and things like that. So there is a couple basic rules. The other one that often is important is to avoid any sort of undercut. So again, thinking of a classic 2-part mold, as the mold opens, the part has to come out. An undercut would be something that prevents the part from being injected from the mold. So anything that restricts it. And there's all sorts of techniques on how to work around that. Words of wisdom for injection molding. So with this, it's truly a team sport. It's rare that anybody will design the part all the way to a tool-ready design, but the trick is to get your mold maker involved early so that you can have a dialogue and understand the trade-offs, and then really leverage their expertise to end up with a great tool in the shortest amount of time you can at the lowest cost. I'm Scott Miller, the CEO and co-founder of Dragon Innovation, and also a co-founder of Bolt.